Welcome back to the show, team. My name's Amelia, and today we have yet another awesome guest on the show. It's a very, very cool title. We have Dr. Georgina, who is a senior lecturer in forensic chemistry. Welcome to the show, Dr. Georgina.
Thanks, Amelia, for having me.
It's an absolute pleasure. I think it might not be too hard a question. Very curious, what is your job?
So, I'm a forensic chemistry academic, which means my time is split between teaching, which I teach in forensic science, chemistry, and scientific research, as well as doing out my own research projects across different areas of forensic science.
I don't think forensic science ever got not cool. What kind of what is covered under forensic science?
Forensic science can really be anything because it's any type of science that you decide to apply to a criminal investigation. But my specialty is forensic chemistry, meaning I'm focused on using instrumental chemical techniques to try and analyze types of evidence that you might find at a crime scene, like fibers or bits of paint, or even using chemicals to detect fingerprints.
I feel like this is definitely something we may have seen represented in the media and might not be represented super accurately. What sort of stuff can we identify or understand better using chemistry in forensic science?
So, when you're analyzing bits of evidence that are left at a crime scene, what you're really trying to work out is what it is and where it possibly came from. The reason that chemistry can help with those answering those questions is because we can chemically analyze a sample to see what it's made out of and then compare that chemical profile to other samples that we might have taken from suspects or from victims or other sources that we think might be linked to that sample. So chemical analysis really helps us to draw the links between the people and the places or the objects that have been involved in a crime.
So instead of holding up like a thread of fabric and being like, this looks like it could be from like that person's jacket, you can actually, I guess, get some sort of chemical fingerprint to help match them up and be like definite and certain.
Yeah, exactly. I mean, it's never exactly certain, especially with things like clothes, because even if you can narrow it down to a particular sweater, that sweater might be one of thousands that have been made. But being able to get a chemical profile from something is a lot more certain than just looking at it by eye, especially because people aren't always that great at being objective when they're comparing things. One example that I often use is the dress, where depending on how you perceive the light in the image, you had the same dress being perceived by some people as white and gold and other people as blue black. The exact same thing can happen when you're looking at fibers from a dress or a sweater or anything else, and similarly for other types of evidence. So, having the chemical profiles, those should be constant and they should be reliable.
It's a way of removing some of that ambiguity that comes with working with human beings.
Yeah, and when you have a criminal investigation where someone's potentially going to be found guilty of a crime, that's really important.
Do you actually do work that is like that goes to court?
That's a question I get a lot. I don't, but I work with the forensic scientists at Chem Center who do all of the chemical analysis for the WA police. So while I don't work on cases directly, my research is focused on trying to help the people that do.
So there's quite a close link between the research that you do and I guess it getting applied in the real world.
Yeah, when we do our research, we want to make sure it's something that's actually going to be useful. So we have close working relationships with the actual forensic experts to try and work out what are some of the questions that they want answered, or what are the areas where they need more information so that when they go to court, they're able to talk confidently about the evidence that they're presenting.
That makes sense. It's not a field about which we know everything.
No, it's a field that is always evolving. And so we're constantly needing to do more research to work out what we can do and whether we can do it reliably.
What's something that you're researching or improving at the moment?
My current project, believe it or not, is analyzing makeup. I'm
Really?
looking at, yeah, I'm looking at whether you can take a trace of something cosmetic. So let's say a lipstick print that's been left on a glass at a crime scene. Can you take the tiny little bits of lipstick that have been left on that glass, analyze it, and determine what specific lipstick it is? Could you then try and link it to a lipstick that you've taken from a victim or a suspect and show that they're the same? And you might think that that sounds easy, but when you're dealing with micro traces, it can actually be kind of difficult.
It I mean, on the surface, it sounds easy, but at the same time, there's a lot of lipsticks out there. Are all the different lipsticks, like, really different?
Well, that's what we're interested in working out because lipstick is only going to be useful evidence if different lipsticks are actually different, if we can tell them apart. So,
Mm.
what I'm doing is getting a big collection of lipsticks and analyzing them, comparing all the data to see, firstly, whether we can tell them apart when we have large amounts straight from the lipstick tube, then what happens when we only have trace amounts, and then what happens when those traces have been exposed to the environment, because in an actual crime scene investigation, you don't get to come along right after the crime's been committed and then immediately start analyzing things. What happens if you've got a lipstick print that's been outside for a while or it's gotten wet? Does that affect the results that you might get?
How many lipsticks are there in your lab now?
We have upwards of about 50 samples, and that's nowhere near the amount of lipsticks that are out there. And we're only focusing on ones of a very similar color. So we're always looking for opportunities to expand our collection.
I love everything about the mental image I have right now is fantastic.
It was really cool because we actually took a photo. I sent one of my coworkers who was helping me with this research out on a shopping trip with the company credit card and went, look, just get however many lipsticks you can get up to this value. And she went off and had a shopping spree at Sephora and came back with like 20 new lipstick tubes.
I feel like that could have been a very entertaining discussion with the person processing that transaction.
We did have to give finance a heads up and say this isn't for personal use, it's actually for science.
Is that something that has been done overseas? Like, is there a body of research into lipstick analysis?
Yeah, there's not a massive amount of research out there, but there have been groups in Poland and in India and in the US that have looked at lipsticks. But what we're trying to do is look at it much closer. So we've actually gone to the Australian Synchrotron over in Melbourne, which is a high tech facility, essentially an electron racetrack. It whizzes electrons round and round at nearly the speed of light. And that means that we can generate really, really bright infrared light to take our chemical profiles, even down to the micron level. So, whereas other studies have generally looked at relatively large amounts of lipstick, we're trying to see what happens on the micro scale.
It's just fantastic. You never know what skills you might need, clearly. What are some other, like, lipsticks is cool, but what are some other examples of, like, research that you've done?
So, outside of trace evidence analysis, one of the areas that I'm interested in is fingerprint detection. So I've got a PhD student who I'm co-supervising who has been working on how old can a fingerprint be before we can keep detecting it. He actually managed to detect a finger mark on a journal dating back all the way to World War II.
No way. That's amazing.
Yeah, it is the oldest fingerprint that's ever been developed using that particular technique that he was using.
I don't know what I'd assumed. Like, maybe that they sort of dissipated in about a week or so, which doesn't make sense, really.
Well, that's what's really interesting about finger marks. We were looking at finger marks on paper. This was in a journal, somebody's diary that they were keeping. And with paper, because it's porous, it can absorb some of the secretions like the sweats or the oils that are on your skin that make up your finger mark. So it turns out that if that document or that journal is then kept stored away from lots of air exposure and away from moisture, the paper actually almost preserves the fingerprint.
So if it had been like a shiny material, like say the outs, well, obviously the outside is going to be different because that'll be affected, but like would a shiny thing that didn't absorb the oils, would that not last as long?
That's what we think. If we were looking at something like a glossy tile, for example, finger marks don't seem to last quite as long because they sit on the surface and they can get washed away or wiped away.
Hmm. That's amazing. That's such an old fingerprint. That's really cool. What does an average day at work look like for you? Presumably, it's not all like arranging lipsticks in alphabetical order.
Much as that'd be fun, no. So most of my job is based on teaching. So in the morning, I'll typically start by looking at any questions that the students have sent through and going through my course notes before I head off to teach a couple of classes. In between classes, I'll catch up with the students that I'm supervising to see how their research is going and plan what they're going to do next. I'll maybe catch up with some coworkers for coffee to talk about what we're planning to do for upcoming classes and also work on any side projects of my own.
That sounds like a pretty balanced day.
One of the things I like about my job is that it's slightly different every day. I'll go teach different classes, I'll meet with different people, and I get to do a little bit of all the things that I like.
What are some of the things that forensic science students like might get to learn?
So, for our forensic units, we start off with basically what is forensic science? How do you actually get from a crime scene to presenting evidence in court? So, we might talk about the legal system, what makes evidence admissible, how you actually process a crime scene. We'll talk a little bit about how you process and analyze different types of evidence. So, what methods are there for detecting fingerprints? What would you do if you found paint? And then we'll also cover some of the things like what are the ethical issues in forensic science? Or how do we make sure that the analyses that we're doing for forensic purposes is accurate and reliable? So, what's our quality control?
Sounds like a really interesting range of things. I I'm particularly interested, like, what are some of the ethical issues that students need to, like, be aware of?
So, I get the main ethical issue is the fact that you're dealing with potentially identifying information. So, for example, DNA. If you have a sample of DNA where you have taken it from the crime scene and you've collected reference samples from a bunch of different people to compare, once that case is over, what happens to all those people's DNA that you've taken? Does it stay on a record? Who has access to it? And what purposes could it potentially be used for?
That's a for some it's quite an uncomfortable set of things to think about, really, especially if you're I don't know, I sort of feel like maybe the perpetrator deserves to have their stuff left on file, but other people who just happen to have stuff picked up, that doesn't really seem fair if that gets kept around.
Yeah, exactly. And one of the big issues right now for forensic science is the use of genetic or genealogy databases. So things like ancestry.com. What happens if you have the police trying to commission the DNA records from a company like that? Because the people who signed up to that service, they haven't necessarily agreed for their DNA to be used in an investigation. And imagine being someone who's distantly related to someone who's committed a crime and potentially having the police knocking on your door asking questions about them.
But this is one of those areas that's starting to get quite spicy at the moment. It's a very interesting one.
It is. And that's why we want to actually talk about that with our forensic students because otherwise it's something that you wouldn't necessarily consider. But when you think about it, it really is important.
Do you get some interesting debates in the classroom?
Yeah, we do have some interesting discussions because you can see it from both sides. On one hand, yes, you obviously want investigators to have all the information that they can to complete a case, but where does that balance with somebody's right to privacy?
It's like very much at the cutting edge of that discussion, really. What was your pathway from high school to where you are now? Like, was this always the dream for young Georgina?
I think from the time that I was in high school, I always had an interest in forensic science. I was one of the kids who watched CSI and all that, but it took me a long time to work out exactly where I wanted to fit in it. So After I graduated high school, I did a bachelor degree in forensic and analytical chemistry at Curtin. And along the way, I got to do some work placements with the forensic lab at Chem Center and with the forensic division of the WA Police. But neither of those quite felt like the right fit. So as I came up to the end of my degree, I decided to sign up for honors and then a PhD. And while doing my research for those, I started doing some teaching on the side. By the time I reached the end of my PhD, I discovered that I actually really like that combination of doing research and teaching. And so the year after I finished my PhD, I was offered a lecturing position and I took it.
Sounds like a fairly smooth path, really.
By the standard of things, it helped that I always knew what my interest was. I just had to try a few different things along the way to figure out what my place was going to be.
I'm curious about like what didn't fit for you, say working with the police.
I guess the thing that didn't quite fit for me with the police was I didn't get to do as much of the actual analysis of evidence as I think I would have been interested in. A lot of it was going out to scenes and talking to people, and that's obviously really important, but I was really interested in actually doing analysis. On the other hand, when I went to work at Chem Center for a while, it was all analysis. And it felt like I was just stuck in a bit of a rut doing the same thing every day. I wanted a bit more variety. So I discovered that doing research was a way to do a lot of the hands on stuff that I liked, but be able to come up with my own questions. So I had something a little bit different to do from time to time, and then mix that up with teaching so I could actually share what I was learning with other people.
And have like that human interaction as well.
I found it to be a balance between the two. And I'm quite happy now that rather than being on the front lines of a criminal investigation, I'm doing work that helps behind the scenes.
I think it's awesome you had those two opportunities to have like the real world work experience, and you didn't get to the point where you were somehow stuck in one of those roles. You got to sample it and then find something else that worked out better for you. I think that's really awesome.
Yeah, I was really lucky being able to have those opportunities because it let me what it let me experience what it might be like doing that for a job and then being able to decide whether or not it's what I could envision myself doing.
No, I think that's great. What is it about your job that you get particularly excited about? What helps you get up in the morning and get going?
For me, I think it's just being able to dig into questions. I was always someone who was very curious and wanted to know the answer to everything. My job means that I get to come up with a question and actually design experiments that are going to answer it.
That's kind of cool.
Yeah. Plus, I really enjoy being able to share what I do with other people and share with them what it is that I'm working on and why I think it's cool.
Is there anything that's coming up in the future in forensic science, like that you can see maybe experiments that are starting to happen that you're particularly excited about?
One of the things that we are starting to see explored more is this idea of frugal forensics. So, recognizing that not every lab has $1 million that they can throw at new technology and fancy equipment. What if you have a smaller lab, say in a regional area where they don't have a lot of resources? What techniques can we design for them so that they can still do analysis that they need to do? And also in the current, the post COVID era where things like shipping can take forever or there's other things that just are no longer available, what what's our backup plan? What kind of things can we design so that they're sustainable over the long term?
Oh, I like that, making the whole industry a bit more resilient.
Yeah, exactly. Because we have techniques that we use that rely on a single company that makes a single particular ingredient we need. And what happens when that's suddenly no longer available? We kind of assume that what we need is always going to be there, but that's not necessarily the case. So we need to have contingency planning.
Oh. I have to think a bit creatively about how to do different kinds of investigations. That sounds really interesting, actually.
Yeah, and in order to do that, but then have it still be acceptable for courts, that means there's a whole bunch of research that needs to be done into exactly how we do it and whether the results are good enough to be acceptable.
Hmm. Oh, a whole different thing. Yeah, that is exciting. That'll be cool. Is there any advice that you would give to young people who are considering forensics as a career?
My big advice would be to focus on the science first, not the forensic part. In order to be a forensic expert, you need to have a grounding in the basic science, whether that's chemistry, biology, anthropology, whichever science fits your bill. You can learn the forensic part on the job. That's really just how you apply it. But if you don't know the basics, then that kind of career isn't going to work out for you. The other thing that I'd suggest for anyone wanting to pursue forensic science is to get to know the employers who are in your potential field early on and start making connections. If you can find yourselves mentors who can guide you about what opportunities are out there and how to get in touch with the right people who can help advance your career, that's great. Or sponsors who can keep an eye out on opportunities that might be not advertised widely and only come through certain networks where they can pass it on to you so that you have those opportunities. That's really important for a very niche field.
I think that's awesome advice. Is there any advice that you wish you could give to younger Georgina?
I think the main advice I would have given to myself 10 years ago would just be not to be so hung up on the details and to think more broadly. I think I had a tendency to be really narrowly focused that this was exactly what I wanted to do. And over time I've worked out that yes, okay, that can be what I want to do, but it's good to try other things and have a broad range of experience.
I think that's pretty important advice for a lot of people, really. There can be a number of ways of achieving the same thing or similar things.
Yeah, exactly. There's no one single pathway to where you want to be. And I'm finding now that the range of experience I've had is what makes me better at my job.
How do you find that sort of shows up?
So, as an example, I spent a bit of time working in a soil analysis company, completely unrelated to forensic science, just because I figured, hey, before I commit to an entire career in this, I may as well see what would happen if I decided to go in a different direction. And for one thing, I decided that I really did like where I was already and I wanted to stay doing forensic science. But the environment working there, learning about what the different priorities are when you're working in an industry job, some of the techniques that they used, I was able to use that to develop new assessments and new ways of teaching in chemistry based on what I'd seen actually being done out in the field.
Fascinating. So there was enough of a crossover between forensics and soil analysis.
This was actually for a analytical chemistry unit that I teach, where we want to emphasize that analytical chemistry can take you in all sorts of different directions. And having tried working in forensic labs and soil labs in different places, meant I could go, look, as an example, here are the list of places that chemistry has been able to take me.
And that's going to be so much more inspiring for students as well to to actually be able to hear that you've had those different jobs.
Yeah. And especially because it also points out these are the opportunities that are open to you. There's not much point me telling them all about what it's like to be a chemistry academic when that might not be what they want for themselves.
No. And we can't have a whole classroom of students all becoming the same kind of academic either, possibly. Is there, and I feel like there will be a lot of myths in this area, but are there any particular myths or misconceptions that you would like to take this opportunity to do a bit of myth busting?
Yeah, there are a lot. So on the forensic side of
A lot.
things, yeah, on the forensic side of things, the big myth is, oh, it must be like CSI. It definitely isn't. Some of the technology that exists on CSI just doesn't exist or it's so expensive that only the top end labs can have it. Most forensic investigators don't get to go around interviewing suspects, walking around the crime scene in designer clothing, and cases can take months, years to solve rather than just being, I immediately take my evidence, I get my analysis, here's my results, and the suspect confesses. It's a lot harder than it looks.
So it's slower. There isn't quite the shiny things. Are there any myths that students sort of believe about the field before they get started?
I think the biggest myth or the biggest misconception that forensic students have is that forensic science is infallible, that it gives you definite answers and you will get the right person. In actual fact, there's a lot of questions in a forensic case, and sometimes you can't solve them entirely. One of the big things I always tell my students is you can't say this shows that the suspect is guilty. You can't necessarily prove that, and it's not your job to prove it. It's your job to provide information so that the courts can decide for themselves.
Oh, that's a really interesting one. Like the certainty, but also, yeah, your job isn't to be doing that sort of next, the necessarily the connecting of all of the dots.
No, they're as a forensic scientist, you're responsible for one little piece of the picture, not the whole thing. And even though you might have a bunch of information that means you're making an informed judgment, you can never be certain. You weren't there, you didn't see it. We can only be as accurate or as certain as our techniques, and our techniques aren't 100% guaranteed. It's possible to make mistakes, and we have to be open to that possibility.
Can see that making some people feel very uncomfortable.
So that would be the big myth on the forensic side. As far as general chemistry goes, I think one thing I want people to understand is it doesn't have to be hard. And it's not necessarily complicated either. When you're making dinner, when you're cooking, you're doing chemistry. When you're doing your dishes, that's based on chemistry. Chemistry is in everything that you do. It's not something that's has to be it's not something that you need a whole degree in to be able to understand.
It doesn't have to be unreachable.
No, it's literally in all of our everyday stuff, there's going to be some sort of chemical link. So there it really is for everyone.
Why do you think people are scared of chemistry or do feel like it's particularly hard?
A lot of people say to me, "Oh, I was never that good at chemistry in school," or "I found it really tough in school." And I guess because people have that initial experience where it's kind of presented in school as something that isn't the easiest subject, they kind of carry that expectation with them as as they then leave school, and they keep thinking that chemistry must be something that's difficult. Only smart people can do it, or only people who are really into science can do it.
Mm. But in reality, we're doing it. Well, yeah, a lot of us do a lot of chemistry, and it's not all
Just
unreachable.
yeah, and I guess just the fact that chemistry is a lot of fancy sounding names with weird looking equations, it sometimes seems like it's another language. So automatically that makes it seem like it must be difficult. You have to speak that language in order to get it.
If someone heard you say that and was like, oh, okay, chemistry could be for me. Have you got any examples of where, like, the average person who maybe likes to bake some bread or cook, caramelize some onions or something, where they could sort of start investigating a little bit more?
So I guess as an example, if you're baking some cookies and you're using baking soda to help something rise, that's actually a chemical reaction between something acidic that's in your recipe, something like vinegar, say, although I'm not sure why I'd be using that in baking, and it reacts with baking soda to produce carbon dioxide, which we know that's a gas. So it's making bubbles, and that's what's making your piece of pastry actually rise. So that's an example of where chemistry kind of comes into it. And you can look online and you can find that There's plenty of websites out there that actually break down what's happening on a chemical level that is explaining why food is changing between your raw ingredients and what you actually want to eat.
Well, I think I found out what I'm going to be doing for the rest of my evening.
Yeah, it's really fascinating just all the different chemical processes that are involved. And I always say that, hey, if you're doing baking, if you're making a meal, you're essentially doing a chemical synthesis.
That's going to make a lot of people feel really, really smart right now.
This month, you are following a you are starting with reagents, your ingredients, and you're going through a particular process and you're ending up with something delicious.
I love it. This is the kind of science communication the world needs more of, is cooking based.
I always find that food makes the best analogy. I think people like stuff that relates to food.
Yeah, I agree. This might be a weird question, but do you have like a favorite chemical process?
That one's tricky. I got to admit, I don't do so much. I don't do a whole lot of the chemical synthesis because I it wasn't my strength. I could either make a lot of really good quality stuff, or sorry, a lot of really average quality stuff, or a small amount of really good quality stuff. I don't know. I don't remember what specific process it was, but I remember one of my favorite experiments that I did in my undergraduate degree was an esterification reaction. So, combining an alcohol and a carboxylic acid, so vinegar is an example of that, but there's lots of other related acids, to actually make a new product, an ester, which has a really distinct smell. And depending on what alcohol and acid you use together, you can end up with all sorts of different smells. Esters are actually what they use as artificial scents in a lot of products, including things like lollies. So the one that I made ended up smelling like fruit and rum.
That's really cool.
And it's yet another example of how chemistry relates to food.
Yeah. Are there any of those experiments you could do at home, do you reckon?
Those on making an ester, maybe not so much, just because some of the equipment that you need is fairly specialized. But there are lots of general science experiments that you can do at home, and I'm seeing more and more chemistry kits for that. So, one of the sorry, going back to forensic science, one of the activities we developed for students to do at home during the COVID lockdowns was actually superglue fuming, where you didn't need anything fancy. You needed some superglue and a container. We suggested just get a plastic takeaway container, use your fingerprints on some aluminum foil, and you can actually develop your own fingerprints doing that process at home. And it's just a small scale, low tech version of what would actually happen in a crime lab.
Okay, that sounds like something we should find the instructions for online because that sounds like a very entertaining science experiment.
Yeah, it's we had a few students actually try it, and it was a lot of fun. Even now that we've come back from the lockdowns, we actually created a class in our forensic unit where they do get to do their own fingerprints using superglue fuming and dye staining, so that instead of just hearing about all these techniques we can use to detect fingerprints, they actually get to see it happen in person.
So important for learning. Is there anything else we haven't talked about that you'd like to share?
Guess just one last message I'd have to anyone considering forensic science or academics as a possible path for them is get as much experience in different areas as you can. Even though you might think that you have a set pathway that you want to go down, it's good to try out different things and to build up a range of skills, which is then going to make you more versatile.
I reckon that's fantastic advice. Yeah, because you never know what random skills you'll pick up doing side jobs or other jobs or volunteering, all that sort of stuff.
Yeah. And it's also important because more and more research now is what we call cross or multidisciplinary, meaning you need different people with different sets of expertise to all work together to solve a problem. So by building up knowledge in different areas, you can make sure that you're always going to have something to contribute.
And some really exciting things can happen at the cross sections between different fields and areas.
As an example, at the research group that I'm part of at Curtin, we, for a while, were doing a collaboration with people who specialized in making nanoparticles because we said to them, hey, could you actually make us some nanoparticles that we could use to detect fingerprints? And so we combined their experience and knowledge in chemical synthesis with our knowledge of how to actually do that in forensic investigations.
That sounds like a fascinating experiment uh, to have given a shot. Did it work?
Yeah, it did. So we're still doing the testing, but so far it looks like a pretty promising method for developing luminescent finger marks, which is really cool. And even if that's something that we can already do using some of the techniques we have, again, it's about coming up with backup plans and having different ways that you can possibly get similar results.
Diversity of options is very important.
Yeah, it's really about not putting all of your eggs in one basket.
Yeah, that's such an exciting experiment to have done. To start wrapping up, do you have a shout out or a virtual high five for someone or someones who you think is doing an awesome job and deserves lots of credit?
I want to give a shout out to my fellow science enthusiast, Dr. Kari Pitts, who is one of the senior mineralogists and forensic experts over at ChemCenter, and her whole team at ChemCenter. They're doing an incredible job under an incredibly high workload. And in between doing all of their analysis, they're out there talking to school kids and doing cutting edge research into forensic science.
They're doing all the things. Okay, then lots of high fives for Dr. Kari and the team. That's a lot of stuff to do.
They do an amazing job of not only doing the research that supports their work, but going out and encouraging young people all over the state to consider science in a new light.
Really important work. Love it. So many high fives for them. Thank you so much for coming on the show, Dr. Georgina. This has been fascinating, delightful, and I think not just some great wisdom, but also some really cool insights into forensic science and chemistry. So thank you so much for being here.
Yeah, thanks for having me. This has been a lot of fun to talk about.